Hello and welcome to this lesson on liquids. You've been learning that the postulates of kinetic theory help explain how the temperature and pressure of a gas are a result of microscopic interactions between the individual particles. Well, the particles of a liquid, such as the droplet of water you see here on the screen, are also governed by the laws of kinetic theory. In this lesson, we will discuss and explain the properties of liquids. But first, let's review the important postulates of kinetic molecular theory. You've probably heard of kinetic theory in association with gases. Well, many of the postulates of this theory apply to all matter, including liquids. First and foremost, we assume that all matter is composed of small particles, and these particles are moving constantly in a random fashion. When they interact, they collide, and they are perfectly elastic in these collisions, bouncing off of each other and then continuing in straight paths thereafter. Why? Because the particles conform to Newton's laws of motion. Newton's first law states that an object will change its motion only if acted upon by an unbalanced or outside force. His second law states that the force is equivalent to the mass of an object times the acceleration of that object. And lastly, that for every action, there must be an equal and opposite reaction. Now, liquids are different from gases in terms of the amount of space between the molecules, but many of these postulates still apply. You have lots of personal experience with liquids. You drink them, you wash with them, you fill your gas tank with liquids, and therefore we want to build on that common experience in this lesson and help you to describe how the postulates of kinetic molecular theory apply to those liquids you use every day. By the end of the lesson, you should be able to describe how kinetic molecular theory explains the properties of liquids, including their compressibility and their shape. Lastly, we'd like to provide you with some practice so that you can use kinetic molecular theory to explain the behavior of liquids.